into equal halves. So if AB is equal to CD, then half of AB is also equal to half of CD. Is that concept very clear? Okay. So AM will be equal to MB because the chord AB is cut into equal halves by the perpendicular OM, isn't it? So we can say that half of AB, that is equal to AM, will be equal to, what is half of CD? Yes, the chord CD, we are taking the half, that means it is CN, up to CN. Mark it as equation 1 and write the condition. How they become equal? Because the perpendicular drawn from the center of a chord will bisect the chord. So using that, we are writing AM equal to CN. Now we have to consider the true triangles that we got formed here, that is AOM and CON. So if we prove that these two triangles are congruent, we can easily say that they are equidistant. Okay, so for that we will take triangle AOM or AMO and triangle CON or CNO. Okay, so in these two triangles, what all things we know? AM equals CN, isn't it? AM and CN, that we have proved before from the one, isn't it? So we will write that condition here. AM equals CN. Okay. And next, do you see anything common here or any equal parts in from the triangle AMO and CNO? Yes, in triangle 1 and 2, we know that OM and ON are perpendiculars, isn't it? So perpendicular means their angle will be 90 degree. So angle 1 and angle 2 is equal because they are 90 degree perpendiculars. Okay. Is there any other parts which are congruent here or equal here? Yes, exactly. OA and CO, isn't it? Because they both are radii of the circle. Therefore, AO equals CO because they are radii. So, radius of the circle are equal. So, using that we got AO equals CO. Therefore, what we can say? Triangle AMO is congruent to triangle CNO. Is that clear? By using which condition? We got one angle and two sides, isn't it? So which property we can use here? Yes, by RHS congruence, because the triangle constructed here are right angle triangle. So which is clear that OA and OC, which are the hypotenuse of the right angle triangle, are equal and the adjacent sides are equal. So from that clearly we can say MO, from the triangle AMO, MO, and triangle CNO, NO will be equal. Hence by CPCT. Okay, that is corresponding parts of congruent triangle. This completes our proof that AB and CD are equal chords which are equidistant from OM and ON. Thus, we proved that equal chords are equidistant from the center. Now, we are going to prove the converse part of the theorem, that is, chords which are equidistant from the center are equal. So let's see how the proof goes. Okay, for that, so we have to construct a circle with the center A and let the two chords which are equidistant from the center be, name it as CD and EF. Okay, so it is mentioned that these two chords are equidistant from the center. Okay, so let that distance be denoted as AG and AH. Is that clear? So that from the center, the chord CD is at a distance AG and the chord EF is at a distance AH. Now what we have to prove is that we have to prove these two chords, that is CD and EF, are equal. Okay, so we will first point out what is given. So we have these two chords are equidistant from the center, that is AG will be equal to AH. Clear? Now let's join the point C and